Hello, I'm Bruce Yaney, and today in Homemade Science, I want to take a look at a puzzle that's been around for a while. It's called the spinning tube trick. The deception starts out with a tube that has an X and an O printed on it. I push down on the one end, making it spin, and we only see X's appear as it's spinning. Now I'm going to rub it on my sleeve and try it again. Push down, and now only the O's appear. Did it have anything to do with rubbing on my sleeve? Probably not. But even slowing it down, we either see only the X or the O. Now, it's fairly simple, but I've found some interesting variations that I think you'll want to try for yourself. For example, we can go from shorter tubes to longer ones. We could also change the diameter of the tube. We can go smaller or even smaller than that. Or in the other direction, we can go larger or larger. And then see if we can get this monster one to work. But one other thing I want to take a look at is what's printed on the tube itself. There's actually a variety of options. Now that we see what some of the changes can be, let's take a closer look. The best results are when the length of the tube is a multiple of its diameter. I'll start with this one. It's 4 times longer. As it spins, we see 4 dots, which corresponds to 4 times its diameter. Let's try a length 3 times its diameter. And here we see 3 dots. Twice its diameter, it's going to give us 2 dots. Let's try a little bit longer. Let's try 6 diameters. 6 dots. A tube that's 8 times its diameter should give us 8 dots. And let's do one more. Here's 10 times its diameter, giving us 10 dots. Now, as these tubes spin around on the table, the marks themselves follow a path called a cycloid. I can demonstrate it on a larger scale with this tube that has a green light attached by simply moving it back and forth. If I do that in the dark and then take a picture of it, we'll see that we get a series of them. The green dot on the tube would follow the same type of path as it rolls around the table. Notice that the dot is rotating in the same direction that it's spinning, while the red dot actually has a backspin. Now I've added a second wheel that sits on top of that bottom one, and if I turn it one direction, it spins in the opposite direction. And if I were to move it across the table, it also would trace out a cycloid. In this case, the curves are facing upwards. The red dot would produce a series of these as the tube spins around in a circle. So the tube actually traces out 2 cycloids. The position where we see the marks are at the points. The marks actually slow down and stop momentarily at these positions, while in the middle of the curve is where they're moving the fastest. That's why we can see the red dot in this picture, but we can't see the green one. You could see it from underneath if you had a glass table, or try it with a clear plastic tube. So we're actually seeing the green dot at the bottom of the spool. To prove it, I'll cover the underside with yellow tape. Now when it spins, we see yellow instead of the green. Let's try 2 dots next to each other. The paths chased out would look like this. 3 dots next to each other. Would give us 3 adjacent cycloids. Same end of the tube, but opposite sides. Gives us an alternating pattern, and the cycloid looks like this. Instead of dots, you can put down letters to make words. You don't actually see all the letters at one time. Your brain actually keeps the image longer than your eyes see it. It's called persistence of vision. It's your brain that actually connects the lines of the image together. There's all sorts of designs that you can try for this. Even a straight line gives an interesting pattern. The tube I just showed was fairly small, but we could actually go much smaller than that. This tube was cut out from an old pen. In slow motion, we can see that this tube actually bounces up and down as it spins around. Now, launching small ones is fairly easy, but how the heck do you launch these bigger ones? The solution is using a rubber band. The idea is to stretch the rubber band out and then wrap it around the tube 3 or 4 times. Turn it over, stretch the rest of the rubber band out, and then release it. For bigger tubes, you use a bigger rubber band. You can cut the band to make it longer. For the really big tube, I use several rubber bands tied together. Same idea, stretch, wrap it around a few times, stretch it again, and release. As you can see, the behavior is the same whether the tube is a foot long or whether it's just 1 inch long. Well, I hope you enjoyed this video, and as always, I want to thank you for watching.